We're going to start out in section 4 of Unit 4, and we're going to look at distributing, adding, and subtracting polynomials. So we're going to start out with an example of distribution. Whenever we are working with polynomials, the first thing that we're going to always do is we're going to circle our chunks. And after a while you may not need to actually do this step, but early on I do want you to practice this. So we're going to circle the chunks. I'm going to highlight chunks, or put quotes around it, because that's really not the technical term. Usually they're called terms, T-E-R-M-S, if you want to write that down. I like to call them chunks. And then we're going to distribute each chunk. Distribute each chunk in the first group to each chunk in the second group. And we're going to see the more complicated version of that in section 5. But for now, I still want you to use the same rule, so we're not going to introduce a new rule in section 5, we're just going to see it get a little bit more complicated. So we're going to stick with the same set of rules between the two sections. So first example we're going to do is looking at distributing. And so when we have a problem set up like 5x on the outside, and then on the inside we have something like 2x plus 1. This would be a situation where we would need to distribute. And the reason for that is we have something going on the inside here, addition or subtraction, and on the outside we have another term that is being multiplied. So really, even though you can't see it, there's a little multiplication symbol that's essentially sitting between that 5x and that parenthesis. So that entire 5x is going to be multiplied by each part of the next thing. Now when I say circle each chunk, 5x is going to be a chunk on the outside. On the inside, we have 2x as a chunk, and then 1 is a chunk. And you'll notice that I like to circle the plus sign with it, because sometimes if it's a minus sign, I want to make sure that negative comes along as well. So I will circle the symbol that's before a number, not after a number, only the one that comes before a number. So that's why I circled it with the 1 and not with the 2x. Whenever you have a chunk on the outside and then more than one chunk on the inside, you need to make sure that when you distribute or multiply, you take each chunk on the outside and multiply it by each chunk on the inside. So there's one chunk outside, I distributed it to both of the insides. So everyone is connected to everyone. And then I actually carry out my multiplication. So 5x times 2x, if I were to do that first one, 5x times 2x is going to be 10x to the second power. So x times x is x to the second power. And then I have 5x times positive 1. And when I do that, 5x times 1 is just 5x. So my distributed result here is going to be 10x squared plus 5x. And this would be my final simplified version here. Let's do another example that involves now just addition and no distribution. So, new example. And this time we're going to have 2x plus 1, just like we did above. But we're going to multiply that, or excuse me, we're going to add that to another group, 3x squared minus 4x plus 7. And whenever you see an addition sign sitting between two chunks, you need to make sure you take note, because you behave very differently if that addition sign is there or if it is not. If it is not, you're looking at a multiplication problem that we'll see in section 5. If that plus sign or if a minus sign is there, that's going to cause you to act differently. So because I see a plus sign, I know that all I need to do is check to see if there is something out front to distribute or a power up here that I need to deal with. Something out front to distribute, or a power that I need to deal with. And in both cases, the answer is no. For the first group, I have no power up top, and I have no coefficient, no number, or anything else out front. So those parentheses can go away. I can just rewrite this as 2x plus 1. Same thing with the other group. I have nothing written out front that has to be multiplied by everything. I have no power up top, which means that I can just continue to write all the way across 3x squared minus 4x plus 7. And so whenever you run into that situation, you can essentially drop the parentheses, which makes it a lot easier to continue working on the problem. Now let's look for like terms. Whenever you have an addition or subtraction of a bunch of terms, you need to combine the ones that are similar to each other, that have the same variables. So I have a 3x squared, and that's the only thing with an x squared, so that'll be by itself. I have a 2x and a negative 4x, and those are the only ones with x's in it. And then I have a plus 1 and a plus 7, and those are the number terms. So putting those together, 3x squared, I can just write that out front since it has no other ones to combine with. Cross it out to remind myself that I used it already. I have a positive 2x and a negative 4x, so I'm going to take the positive 2 plus a negative 4, and that's going to give me negative 2x. So use those up. And then finally my number terms, my constants. I have a plus 1 and a plus 7. 1 plus 7 is going to be positive 8. So then this here would be my simplified expression. So 3x squared minus 2x plus 8. Draw a line. Let's do another example together. This time we're going to have distribution and addition, which is actually going to take the form of subtraction. So in this example, we're going to have 5 2x plus 1, so 5 times parentheses 2x plus 1, minus parentheses 3x squared minus 4x plus 7. So a lot of it looks similar to the last problem, just a little bit different, and it's going to cause us to behave in a very different way this time. So first thing I'm going to notice is that there is a minus sign here, not a plus sign. And so I'm going to go ahead and make a change to the way this is written, and I want you to do the same thing. Whenever you see a minus sign in front of a group like that, I want you to change it to plus, and then put a negative 1 right out front as a term. So that negative 1 out front reminds you that you have something to distribute. You're going to distribute a negative 1 to that entire second group in a little bit. So, and you might even want to write a note on the side that says, if subtracting change the minus sign to plus negative 1, and that negative 1 is going to sit right out front joining to that group then. So hopefully that little note will remind you to do that. Then we are going to distribute, and before we distribute we want to make sure that we know what all our chunks are, our terms are, so that we can do that, because we have a couple different distribution pieces happening now. So we have a 5 out front, and that is being distributed to a 2x and a positive 1. So I'm going to take 5 times the 2x and 5 times the 1. And when I do that, 5 times 2x is 10x. 5 times 1 is 5. So that leaves me with 10x plus 5 up there. Over on the other side, we're going to have that negative 1 out front is a chunk. That is the thing that's going to get distributed. Inside, we have a 3x squared as a chunk. We have a negative 4x as a chunk. And we have a positive 7 as a chunk. Notice that I included the negative with the 4x. That's a really important one. If your positives get cut off, your plus sign is not a big deal. It's just more building good habits, but the minus signs are the ones where it can really cause problems. So that -1 out front is going to get distributed to every single chunk inside the parentheses. So it gets distributed here, here, and here. There's 3 distribution steps happening. And so -1 times 3x squared is going to be -3x squared. -1 times -4x. Negative times a negative is positive, so I'm going to write plus. And then 1 times 4x is 4x. -1 times 7 is -7. So now I have all my pieces written out. I've done all the distribution. I have no more parentheses. When you distribute, you've used up the parentheses. You've applied their purpose. And now we want to combine our like terms. So I'm going to go ahead and highlight all the terms with an x squared. Highlight all of the terms with just an x coefficient, or an x with a coefficient. And then all the terms that are constants. And when I write this all together, I'm going to do this in standard form, which means my highest power piece first. So -3x squared will come first. Use that up. Positive 10 and positive 4x are going to be 14x. Cross those out. And then plus 5 and -7 is, if I add those together, positive 5 minus 7 is going to be a -2. And that is going to be my cleaned up expression. So again, the big idea with each of these parts is to figure out how to distribute. If you need to distribute at all in that second one, which you don't, when there's nothing out front, there's no power, and you're adding, then you can just drop your parentheses and clean it up. Or in this case, you distribute a number or potentially distribute a -1 if it was subtraction. We're going to do one last little thing just to look at some weird cases so that you're prepared for it if you run into it. If I asked you to simplify something that looked like 2rx plus 3rt plus 7r minus 5rt plus 2x, what would the like terms be? And this is a little confusing, I think, for anyone. I know it's been confusing for me before. I look at these and they all have an r in them, but that actually doesn't matter. It's all about the complete combination of letters that we are looking for in common. So you'll notice this one has a 3rt and this one has a -5rt. All of the other ones have unique combinations of letters. It's almost as if they're spelling a word and it has to be a unique word. So Rx, Rt, R, and X are each unique things. The only ones I can combine are the ones I highlighted in purple here. So I would have 2Rx that I just copied down. The 3 and the -5 together make -2 if I add those, and I would use the RT letter combination that I have in both of them. And then I would just have to continue to carry down whatever I had before, plus 7r plus 2x. And this is actually as simplified as this gets. You cannot clean that up any further. So that's just something to be aware of if you run into that. Good luck.